And here we go into section 8.3, multiplying binomials. The objective of this section is to multiply two binomials correctly, or a binomial by a trinomial. All right, so we've done some work with adding and subtracting polynomials. Remember that binomials and trinomials are just special cases, special examples of polynomials. Now we're going to move into multiplying them in this section. An essential thing to understand here, there are several ways to find the product of two binomials, so multiple paths to the same solution. Let's consider this problem to get us started. A park has a rectangular dog run with a length of 30 feet and a width of 20 feet. The Parks Department wants to expand each end of each side of the dog run by the same amount, x. What will be the total area of the expanded dog run? Justify your reasoning. Well, let's consider what we have here. We have this original area of 300 feet by 200 feet. That's a nice rectangle. And we can find its area by simply multiplying these two. 30 times 20, 600. So the area of the initial dog run, it's an unfortunate place to be pointing at this dog's, anyway, 30 times 20, 600 square feet. All right, and then we'll consider the areas of each of these other rectangles as they're drawn for us. Because notice the dog run's being extended by x units or x feet in this direction and x feet in this direction, and likewise around the entire dog run. So if we consider that the area of this square, the square in this corner, would be x squared units or x squared feet, and this would also be x squared feet, and so would the other corner. And then we consider with these longer rectangles, which again we have 4 of these, well, that would be 20 times x, and I'm sorry, it looks like we only have 2 of these, and then 2 other rectangles with different areas, but we'll get to those in just a moment. X times 20, well, that's the length times width of this rectangle, so 20x. So 20x would be the number of feet representing the area of that rectangle. Likewise, 20x for this rectangle. And something similar here shows us 30x for these rectangles. 30x and 30x. So here we have the areas of each of these rectangles, all of these components which when added together would represent the area of the new dog run. So if we add these, let's change colors here, we have our 600 square feet. That was the initial area, plus 4 of these x squareds. So I'm just going to combine those 4 right now, plus 4x squared areas, plus 4x squared, plus we have 2 of these 20x's, so I'm going to combine those as well. 20x plus 20x is 40x, plus 2 of these 30x's would be plus 60x. Now combining like terms and rewriting this polynomial in standard form, recall standard form has the higher powers of x to the left. We're going to find, well, 4x squared plus 40x plus 60x is plus 100x plus 600. And notice I left in my units here, my feet squared, and then for some reason I stopped writing those throughout, but we know that we're talking about area in square feet, and 600 is just our constant in the polynomial. So what we find here is that the area of the new dog run will be 4x squared plus 100x plus 600 square units, or in this case, square feet. But perhaps there's a much faster way for us to come at the solution without writing out all of these areas and adding them all together. We'll see. I notice it says there are several ways to find the product of two binomials. One way to find the product of two binomials is to use an area model. Another is to use the distributive property. So we'll investigate this multiplication of two binomials, and we have the solution, but we'll investigate it in terms of an area model and using the distributive property. And then we'll learn another technique for multiplying binomials that you may find preferable to these two. So an area model. We need to understand that what this view we're seeing now represents an exploded version of what used to be a rectangle. So imagine these blue squares, the yellow squares, and the green rectangles all being pushed together so that there were no spaces, and forming a rectangle that has a length of x plus 1 unit. Simplifying like terms, we find that's 2x plus 1, which should seem familiar to us, 2x plus 1, and a width of x plus 2, or x plus 1 units. So essentially this length represents x units, meaning this length also represents x units. Notice that's the same x units as we find on the lengths of the green rectangles. And then 1 unit is represented here, and that's congruent to 1 unit represented here and 1 unit represented here. So when forced together, this could represent a rectangle with a length of 2x plus 1 unit and a width of x plus 2 units. Now, as you know, to find the area of a rectangle, we would multiply length times width. So it makes sense that if we could determine the area another way, perhaps by separating into squares and rectangles and then summing the areas of each of these components, that would give us the product as well. So notice what's happened here is this is separated into rectangles which we can find the areas of quickly and easily. The area of this rectangle, x squared, right? Length times width, or since it's a square, side length squared. This rectangle has a length of x units and a width of 1 unit. X times 1 is x. Likewise, these green rectangles all have areas of x, and these yellow squares, areas of 1. 1 times 1 is 1. 1 times 1, 1. And then we can add these things together, much like we did with the dog run problem. X squared plus x squared, well, that gives us 2x squareds. 2x squareds. X plus x plus x plus x plus x, there are 5 of those, gives us plus 5x and plus 2. And notice, that is what we were told the product of our binomials is to begin with. So there's one technique. And then it's a good way to understand truly what's going on, or a way to visualize multiplying binomials. We'll also investigate a second technique, and that technique is using the distributive property. So let's imagine if we were to multiply x times both terms, let me change colors, x times 2x and x times 1. Notice that's done for us here. And then multiply 2 times both of these terms, 2 times 2x and 2 times 1, done for us here. Simplify, combine like terms, make sure our answer, our polynomial, is written in standard form, and we find 2x squared plus 5x plus 2, which should sound familiar to us. That is also the value that was given to us in the original problem. So 2 methods so far that lead to the same solution, and we'll investigate more.